Hello, my dear students. Today we shall have implicit differentiation and related rates. This is your teacher, Jennifer Basilia de Leon, saying welcome to the last trick of our lesson about differentiation. What does implicit mean? According to the Oxford Dictionary, implicit means implied, though not plainly expressed. In our previous lessons, we have dealt with functions expressed in this form. This week, we are going to deal with lessons, or this week, we are going to deal with functions expressed in these forms. Can you still remember this expression? This is an operator, which means the derivative of a thing with respect to x. So if we have an expression 4x cubed after it, this means that we need to get the derivative of 4x cubed with respect to x. Simplifying this is equal to 12x squared. However, if we have the derivative of y squared with respect to x, this is equal to 2y dy dx. I hope you were able to get the process because we need that when we discuss further the differentiation by implicit. I hope you were able to get the process because we need that as we further study about differentiation by I hope you were able to get the process because we need this skill as we discuss further implicit differentiation. Now to start our discussion about implicit differentiation, let me present to you the steps in finding the derivative of a function using implicit differentiation. The first step is to differentiate both sides of the given equation with respect to x. Note that if a term or factor contains y, use the chain rule by treating y as the u. Or if a factor contains x and y, apply the product rule or the quotient rule as needed. And then isolate all the terms with dy dx on the left side of the equation. And lastly, factor out dy dx and solve for dy dx. Now let's work on the first example. Differentiate x squared plus y squared equals 4. The first step is to differentiate both sides. So all we have to do is to get the derivative of x squared plus the derivative of y squared with respect to x, and then get the derivative of 4. Then simplifying each term, we will have 2x for the first term, and then for the second term we have 2y dy dx. And then the derivative of a constant is 0. Now we transpose 2x to the other side. So at the left we will have 2y dy dx, and at the right we have negative 2x. And then we isolate dy dx by dividing both sides of the equation by 2y, so that we will have dy dx at the left side, and then we simplify the right side, which is equal to negative x over y. So we were able to get the derivative of x squared plus y squared equals 4 by implicit differentiation. Now let's work on with the second example. Differentiate 3y plus the cube of 3x squared minus 5 equals 10. Okay, first we have to differentiate both sides. So we will have this. And then we simplify each term. So we will have 3 dy dx. Now using the chain rule, we will have 3 and then for the constant, we will have 0. And then we transpose the second term to the right side. So we will have at the left 3 times dy dx. And at the right, we have negative 18x times the square of 3x squared minus 5. How did we get 18x? That is 3 times 6x. And then we divide both sides by 3 so that we will be able to isolate dy dx. And then simplify the right side. We will have negative 6x times the square of 3x squared minus 5. So that's the derivative of 3y plus the cube root of 3x squared minus 5 equals 10. Now let's have example number 3. We differentiate both sides. The derivative of x with respect to x is 1. Now using rule number 8, we will have negative sine of x minus 2y times 1 minus 2 dy dx. Now apply distributive property of multiplication by multiplying negative sine of x minus 2y to each term in the binomial. So we will have negative sine of x minus 2y plus 2 sine of x minus 2y dy dx. And then we isolate the terms with dy dx by transposing the first term to the left side. Hmm. And then we solve for dy dx by dividing both sides by 2 sine of x minus 2y. On the right side, we can cancel this. So what remains is dy dx. And on the left side, we can just copy the expression. Now, since we cannot cancel any term, this would be the final answer. So the derivative of x equals cosine of x minus 2y is 1 plus sine of x minus 2y all over 2 sine of x minus 2y. Now let's have y equals ln. Now let's have example number 4, wherein we have an equation involving the natural logarithm. So with this, in order to find the derivative of an expression with natural logarithm, we use rule number 15. So first we get the derivative of the equation. The derivative of y with respect to x is dy dx, since the derivative of y is 1, and then 1 times dy dx is simply equal to dy dx. Now, to get the derivative of the expression at the right, we use rule number 15. So we will have u equal to 5x squared. So u prime would be 10x. Now we will have 1 over 5x squared times 10x. Simplifying this, we will have dy dx equals, take note that we can cancel out 5, so this will be 2 and this is 1. And then for the variable x, this will be 1 and this will be cancelled out. So simplifying this, we will have 2 over x. Therefore, the derivative of y equals ln 5x squared is 2 over x. Let's have example number 5. Differentiate y equals ln of sine 3x. Now, as you noticed, the expression at the right is quite complicated. So, using rule number 15, we will let u be equal to sine 3x, such that when we have u prime, is equal to, using rule number 7, we will have cosine 3x times 3. Simplifying this, we will have 3 cosine 3x. Now, we are ready to differentiate the equation. So we get the derivative on both sides. The derivative of y with respect to x is dy dx. And then to get the derivative of the expression at the right, we use rule number 15. So we have 1 over u. So take note, our u is sine 3x. So we will have sine 3x in the denominator. Then the derivative of u is 3 cosine 3x. Performing multiplication, we will have 3 cosine 3x over sine 3x. We can further simplify this by applying the trigonometric identities. Take note that the ratio of this trigonometric function is equal to cotangent 3x. So simplifying this, dy dx is equal to 3 cotangent 3x. That's it. Now let's try differentiating an equation involving logarithmic expression. So just like what we did in the previous example, we differentiate both sides of the equation, so we will have this. We get the derivative of y, so we will have dy dx. Now to get the derivative of the logarithmic expression, we will use rule number 16. We let u equal to 3x to the fourth power minus 2, and then u prime would be 12x cubed. Now, we follow the format for rule number 16, so we will have 1 over 3x to the fourth power minus 2 ln 5 times the derivative of u, which is 12x cubed. Now, performing multiplication, we will have 12x cubed in the numerator, and in the denominator we have 3x to the fourth power minus 2 times ln 5. Now you may distribute ln 5 to each term in the binomial, so you may have a final answer of 12x cubed over 3x to the fourth power ln 5 minus 2 ln 5. Okay, that's it. I hope you were able to get that. Now let's proceed to the next example. Now let's work on with an example involving inverse trigonometric functions. So just like what we did in the previous example, we get the derivative of the expression on both sides. So we will have this. Now to get the derivative of y with respect to x, we will have dy dx. And then to get the derivative of the expression at the left, we use rule 21. Now we let u be equal to the square root of 2x, which can also be written as 2x raised to 1/2. Now we get the derivative of u, so applying the chain rule, we will have 1/2 of 2x raised to 1/2 minus 1. Now we get the derivative of 2x, that would be 2. So simplifying this further, we will have 2 over 2 raised to, or 2 times 2x raised to 1/2. Since the result of 1/2 minus 1 it would be negative 1/2. So we need to remove the negative sign by writing the expression in the denominator. Then simplifying further, we can cancel this. So simply the derivative of u would be 1 over the square root of 2x. Now going back to the main problem, we will have the secant of, or the inverse of secant would be, we're going back to the main problem, the derivative of the inverse of secant u would be 1 over u, so absolute value of u. So that means absolute value of 2x. x. And then the square root of u squared, so that would be the square root of 2x raised to 2 minus 1 times du dx. That means we have to multiply this by 1 over the square root of 2x. Now simplifying the expression at the right, we will have 1 over the absolute value of the square root of 2x would be 2x. And then we multiply this, so we will have the square root of 2x times the square root of 2x raised to 2 would be 2x. So we will have 2x minus 1 under the radical sign. Now simplifying further, we will have the square root of 2x times the square root of 2x would be 2x. So in the denominator, we will have 1 over 2x times the square root of 2x minus 1. So the derivative of the equation above would be 1 over 2x times the square root of 2x minus 1. Now let's challenge ourselves by differentiating y equals the inverse of sine of 4x squared all over x minus 1. So since this is a ratio, we will apply rule number 6. And then since the expression involves the inverse of sine, we will use rule number 17. So let's have first rule number 6 in differentiating a ratio. We have to determine first the u and the v. So our u is sine -1 4x squared. So the derivative of the inverse sine 4x squared, following rule 17, we will have u prime equal to 1 over the square root of 1 minus 4x squared raised to the second power times the derivative of 4x squared, that would be 8x. So simplifying further, u prime would be 8x over the square root of 1 minus 16x to the fourth power. And then our v is x minus 1, so our v prime will be 1. Now we are ready to work on with the main problem. So we get the derivative on both sides. Get the derivative of the expression on both sides, so we will have this. Ate Celine, buksan mo daw si Papa. Ate, buksan mo si Papa. Buksan mo si Papa. The derivative of y is dy dx, and then applying the rule number 6, we will have v u prime. So v is x minus 1, then u prime is 8x over the square root of 1 minus 16x to the fourth power. Okay, minus u v prime. So u is the inverse of sine of 4x squared times 1. And then the denominator, is b squared, so x minus 1 squared. So all we need to do is to simplify the expression at the right. Okay, so now in order to simplify the numerator, we have to multiply the second term by the square root of 1 minus 16x to the fourth power, so that we can write it using a single fraction bar. Then after writing the numerator using a single fraction bar, we can just get the inverse operation and then the inverse of the denominators. So we will have to multiply 1, or we have to multiply by 1 over the square of x minus 1. Now simplifying this further, we will have this. Now the problem is we have a radical sign in the denominator. So in order to remove this, we have to multiply both the numerator and the denominator by the square root of 1 minus 16x to the fourth power. So we will have 8x times the square root of 1 minus so we will have x minus 1 times 8x times 1 minus 16x to the fourth power minus 1 minus 16x to the fourth power times sine negative raised to negative 1, or the inverse sine of 4x squared, all over 1 minus 16x to the fourth power times the square of x minus 1. Okay, so that is the final answer for the derivative of y equals inverse sine of 4x squared all over x minus 1. You might be wondering about how can we apply the concept of implicit differentiation. With this, may I present to you situation number 1. Find the equation of the line tangent to a circle defined by 4x squared plus 4y squared equals 36 at 0, 3. In the previous lesson, we have learned that we have to get the derivative of the function describing the curve in order to find the slope of the tangent line at that particular point. So we shall do the same. We get the derivative of 4x squared plus 4y squared equals 36 by implicit differentiation. So we will have now simplifying the first term, we will have 8x. Then the second term, we will have 8y dy dx. And then the derivative of a constant is 0. Isolating the term having dy dx, we need to transpose 8x to the right side. And then we divide both sides by 8y in order to solve for dy dx. So at the right side, we will have negative 8x over y. We can cancel 8, so by dividing 8 divided by 8, we will have 1, and we also have 1 in the denominator. Simplifying, we will have negative xy. Now remember that this is the derivative of the function or the equation 4x squared plus 4y squared equals 36. And this is equal to the slope of the tangent line. Now, since the slope of the tangent line is given by negative xy, substituting the coordinates of the point 0, 3, we will have negative of 0 over 3. Simplifying that, we will have 0. So therefore, the slope of the tangent line is 0, which implies that it is a horizontal line. Now to get the equation of the tangent line, we use the point slope form of an equation of a line. So we will have y minus 3 equals 0, x minus 0. Then the right side would be equal to 0. Then the right side would be equal to 0. The left side would be y minus 3. Transposing 3 to the other side, we will have y equals 3. Y equals 3 is indeed a horizontal line. Now confirming this with our graphing calculator, Desmos or GeoGebra, we would be able to see that 4x squared plus 4y squared equals 36 illustrates a circle. And then the tangent line at 0, 3 is indeed a horizontal line having an equation of y equals 3. Now let's have situation number 2. Find the equation of the line tangent to the curve defined by y equals ln of x plus 2 at 18, 3. So since we have an expression involving the natural logarithm, we are going to use rule number 15. First, we have to get the derivative of the expression on both sides. So we will have now getting the derivative of y with respect to x, we will have dy over dx or dy dx. And then at the right side, we shall use rule number 15. So our u is equal to x plus 2. Then our u prime would be equal to 1. So we will have 1 over x plus 2 times 1. So we will have dy dx equal to 1 over x plus 2. Again, take note that this describes also the slope of the tangent line. Now replacing the variable x with 18, we shall have 1 over 18 plus 2. Therefore, the slope is equal to 1 over 20. Now using the point slope form, we will have y minus 3 equals 1 over 20 times x minus 18. Now, apply distributive property, so we will have 1 over 20 x minus 18 over 20, which when simplified, divide both numbers by 2, we will have 9, and this is 10. Then transpose negative 3 to the right side, so we will have y over 20x minus 9 over 10 plus 3. Okay, which when simplified will give you 1 over 20x minus 21 over 10. So this is now the equation of the tangent line to the curve defined by y equals ln of x plus 2 at 18, 3. Now let's confirm that using our graphing application. So we graph ln of x plus 2, we have this green line, and then the tangent line, which is y equals 1 over 20x plus 21 over 10. Surely they meet at 18, 3. That confirms our answer that it is correct. Now let's explore further how we can apply the concept of implicit differentiation in our real life. After a rescue operation in a fire incident, a member of the rescue team removed a ladder by pulling the foot of the ladder away from the wall where it was leaning at a rate of 2.5 feet per second. If the ladder is 25 feet long and its foot is 12 feet away from the wall, how fast does it stop slide down the wall? To solve this problem, we have to illustrate first the given data. So let x be the distance of the foot of the ladder from the wall and y as the height of the wall. such that we can form an equation of x squared plus y squared equals the square of 25 feet. That is by applying the Pythagorean theorem. Now we can solve the, now since we know that x is equal to 12, we would be able to solve for y. So by substituting the known values to the equation, we will have this. Now solving for y, we will have, now solving for y, we will have the square root of 25 squared minus 12 squared. So we will have the square root of 625 minus 144. That is approximately equal to 21.93. Now let's make use of the other data given in the problem. Now 2.5 feet per second is the rate when the foot of the ladder is being pulled away from the wall. So this means that 25 feet per, or this means that 2.5 feet per second is equal to the change in x over the change in time. Now, since we are asked how fast does it stop slide down the wall, this means that we need to find the change in the vertical height over the change in time. To solve for this, just like in solving optimization problem, we need to get the optimization equation. This time we will be using this as our working equation. Now, if we will have x squared plus y squared equals 25 squared, we differentiate both sides, so we will have d, the derivative of x squared, plus the derivative of x squared with respect to x, plus the derivative of y squared with respect to, we will get the using x squared plus y squared as our using x squared plus y squared equals the square of 25, we are going to differentiate both sides of the equation with respect to time. So we will have to get the derivative of x squared with respect to t plus the derivative of y squared with respect to t equals to the derivative of 25 squared with respect to t. Simplifying each expression, we will have 2x dx dt plus 2y dy dt equal to 0. Now substituting the known values, okay. Now isolating the term having dy dt, we will transpose to x dx we will transpose the first term to the right side, so we will have negative 2x dx over, transposing the first term to the right side, we will have negative 2x dx dt. And then solving for dy dt, we divide by 2y. So dy dt is equal to negative x dx dt over y. Now replacing the variables with the given values, we know that x is 12. Now dx dt is 2.5, and then y is equal to 21.93. Simplifying this, we will have negative 1.37. Now answering the main problem, how fast does it stop slide down the wall? We can say that the top of the ladder slides down the wall at the rate of 1.37 feet per second. As you can see, we did not affix any more the negative sign, because this negative sign implies that the ladder is sliding down. Now let's have the second example. Now consider sample problem number 2. In the Raga public market, X thousand crates of bananas are supplied daily. Each crate costs P pesos, and the supply equation is Px minus 20P minus 3x plus 105 equals 0. If the daily supply decreases at the rate of 250 crates per day, at what rate will the price change when the daily supply of crates reaches 5,000 crates? Now to start our solution, we define first the variables that we are going to use in our solution. Let T be the time elapsed expressed in day, P for the price per crate of bananas expressed in pesos, X for the supply of bananas in thousands of crates, dP dt, which is the rate of change in the price of bananas expressed in pesos per day, and dx dt equals to negative 250 crates per day, or negative 1/4,000 of crates per day. And then we use the given equation as an equation relating the quantities. So with this, we solve for P when X is equal to 5. So substituting the value of X in the given equation, we would be able to get P equals 6. Now, we have to differentiate the expressions in the equations. Now we have to differentiate both sides of the equation relating the quantities. Papa, madikluhon? Inon ko nga yun. Madiklum ako. We differentiate both sides of the equation of the we differentiate both sides of the equation relating to quantities, so we will have we would be able to get dp over dt equals negative 0.05. So with this, we can say that the supply, therefore, when the supply reaches 5,000 crates of bananas, its price will decrease to 5 centavos per day. Now let's work on with the last example. In J&B Bake Shop, the baker is making a spherical dough so that its volume increases at the rate of 5 cubic inches per minute. At what rate will the radius increase when its radius is 6 inches? So we define first the variables that we are going to use in the solution and determine the equation relating the quantities. So since we are dealing with volume, we will have V equals to 4/3 pi r cubed. Now, differentiating both sides of the equation, we will have differentiating both sides of the equation, we will have dv dt, and then we will have 3 times 4/3 pi r squared. We deduct by 1 degree, and then dr dt. Now, simplifying the equation, we can cancel this so that our equation will be simply dv dt equal to 4 pi r squared dr dt. Now, we know that dv dt is 5, r is 6, so we can solve dr dt. Now dividing both sides by 24 pi, we will have dr dt equal to 5 over 24 pi. Now, mali. Now, substituting the known values in the equation, we will have 5 for dv dt. Then we use 3.14 per pi. Then r is 6. Then we don't know dr dt because that is what we are asked to look for. Now, simplifying this, we will have 5 equal to 452.16 dr dt. Now dividing both sides by 452.16, we will have dr dt equal to approximately equal to 0.01. So therefore, when the radius of the dough is at 6 inches, its diameter increases at the rate of 0.01 inches per minute. I hope you were able to get our lesson for today. Just in case you have questions, please comment down below and then I will respond to your questions. Thank you and see you again.